Right, okay, so I am here to tell you whether or not it is Christmas. Only for that didn't do anything. Why is it not working? Maybe I'll make it a little smaller so I can see what I'm doing. There we go. I'll make it bigger again. Right, okay, so is it Christmas? Well, obviously I can ask APL whether the month and the day is 12 and 25, or if you celebrate Christmas on a different date, adjust accordingly. But they aren't... Yes, so it'd be 24th, I think, shouldn't it? Yeah. Yeah, well, I've lost... It's gone anyway, look at that. It's disappeared. Let's try again. Okay, so we're in Denmark. This might make a difference. Let's have a look. 24. No, it's not Christmas. Okay, there you are. Thank you very much. Right. Obviously, the next thing we might want to ask is, how long is it till Christmas? So let's put the current timestamp in a variable called now, or name it now. The reason I'm going to name it because I want to use it over and over again and not distract you by the fact that that constant quad TS is changing. So I'm going to use that date all the time. And that's when Christmas starts. So let's ask how long it is until Christmas. And it is 0 years, 3 months, 16 days, minus 16 hours, minus 58 minutes. 5 seconds, etc. So obviously that's rubbish. That's no good. We can't do it that way. So let's look at what other thing we've got in the interpreter already. There is this method called date to IDN. IDN stands for International Day Number, apparently. It takes a date, it takes the date element of now, just the date, and turns it into a numeric count, which is the number of days since the 31st of December, 1899. So I'll put that in a function and use that to get the day numbers for Christmas and now. And obviously then I can tell you that it is 107 days until Christmas. But that's only days. I haven't got any hours, minutes and seconds there. So let's try and work out the time in there as well. We can decode the hours, minutes, seconds, and milliseconds to create the number of milliseconds through the day that we are, divide by the total number of milliseconds of the day, and we can tell that we're about 0.7 of the way through the day. Yeah. So put those two together, we can now represent any date and time as a floating point numeric value. And those are the two floating point numeric values for the start of Christmas and today. So now I can tell you that we're 106 days, 0.292, and I could obviously turn that back into hours, minutes, and seconds, but time I don't think will permit, so that's an exercise for the reader. Okay. Show you something else. This is a bunch of random numbers. They are completely random numbers, but they also have the property that they look a bit like a timestamp. And they look like a valid timestamp. So I'm going to create 1,000 of the things. There's the first two. Think that you might have, if you've got a database with a column of dates and times in, you could theoretically store 1,000 quite easily, and if you did, they would occupy 56 kilobytes of memory in the workspace. If, however, we convert those using our existing function to floating points, there's the equivalent of the first two. They only take 8K of memory in the workspace, which is roughly 1/7. So there are two advantages to why you might want to deal with dates and times in a different format to the quad TS format that we've got. You can do calculations on them, and they take a lot less space. So having written all those functions to do that conversion, let's look at quad DT as it's currently spelled, which is in this 18.0 interpreter. And it will do that conversion for you. And the right argument are the two timestamps that I want to convert, Christmas and now. The left argument is what I want to convert from and to. The 2 is the 1, which is the same format that I showed you just now. And neg1 is a timestamp format. So that function will generate the same two numbers that I calculated earlier with the function. This is just showing you that I can abbreviate the left argument because it can see that there are timestamps on the right, so I will not convert them to those international day numbers. Give it the same answer. So we'll subtract one from the other, that's the number of days till Christmas again. let's just do that one more time. Here I'm running a round trip, so I'm going to convert to an international day number and then back to a timestamp and get exactly the same one that I started with. The accuracy of a floating point for storing these things depends to an extent on the magnitude of the integer part, but it's roughly a few tens of milliseconds, and quad TS is it's a few tens of microseconds, and quad TS is milliseconds, so it's well within the accuracy of quad TS. There's a simple calculation. I can add 250 days to today, and that takes us into 16th of May 2020. Right. So, day 0 was the 31st of December 1899. I don't know why that was chosen, but that's the arbitrary start point. So obviously day 1 is the first day of the first month, 1900. I'm being asked a question. Do you want to? Yeah, there is a bug. Yeah, you're going to see that later on, actually. It could have been the 1st January 1900, but they counted the 29th of February 1900, which didn't exist. Yeah. But either way, it's an arbitrary point at the beginning. What I wanted to basically just show is that we are not confined to dates beyond the 31st of December 1899. Clearly, if you go backwards, then we go back half a day, we end up at noon on the 30th of December 1899. These things can represent pretty much any date. There's 100,000 days before, which happens to be the 17th of March 1626, for example. So if you've got some really old data, you can still use this. Sorry? Right, I was asked whether it's doing the Gregorian to Julian. No, I can't remember the name of the thing, so I'm going to do something just to get it to display it. So, neg 1, quad E. I hate doing these things when I'm at the front here. Here we go. Right, they are in the proleptic Gregorian calendar, which is essentially the current calendar applied backwards as far as you can go. So it's the Gregorian calendar, apparently, but it's got a name. Right, so I've got to bring that other line back, haven't I? Don't know. Why different error messages? I'm not sure offhand. Right, let's go forwards again. Okay, so there are other timestamps in the interpreter. You may have seen these if you use component files. Let's create a file, write some data to it, read the data, and now let's read the component information, and we get 3 bits of information: its size, the user who created it, and then this timestamp, which is another numeric, and it's actually defined as the number of 60ths of a second since the 1st of January 1970. So let's get that out on its own. Of course, this quad dt function can deal with those as well. So we'll convert from type 2, which is what that is, to type -1, which is a quad ts, and we get a sensible, meaningful date we can actually understand. We can convert between any 2 formats. So here I'm going to go from a type 2 to a type 1, and I get the international day number. We have defined a whole bunch of these. So I've shown you 1 and 2, which are international day numbers and component files. We've defined, we can support Unix time, which is whole seconds since the same epoch, various Julian time variants, which are used mainly in astronomy. Julian time is 4, and then it's the epoch of that is 5,000 years or so ago. So there are other forms which have got different epochs. Let's have a look at one of those. So that's typically the value for now as a Julian time. We've got Microsoft Win32 file time support and another Microsoft format. These numbers are huge because they are the number of 100 nanosecond ticks since the 1st of January 1600 and the 1st of January 1. So those numbers get enormous. And if you look carefully, that's a dec F because you can't store that in a floating point number. And then we've got the Excel that we mentioned just now. Yes, so let me show you. Look, 28th of February, 1900 is day number 59, and the next day, the 1st of March, is day number 61, which we do support. And
February 29th?
that's exactly what's there now. You would hope to get 60, but unfortunately it fails the is it a valid date check. So no, it doesn't. 14 is a Microsoft OLE automation date, which is a very useful one, and if there's time, I will show you using that at the end. Okay, right. So that is date-time conversion. That is something which I think we're pretty much committed to putting into the next release. The next thing I'll show you, I'm ahead of myself. There's one other thing it can do. It can do military time zones. So not Julian, Juliet time, J, is the current local time in the military time zone. So if I ask for that, I get the current time in Quad TS format. That's exactly equivalent to Quad TS. But I can ask for other time zones. So that is the current time in UTC. That's Zulu time. If I ask for both together, I think you can see where I'm going with this. I can subtract one from the other, multiply up to hours. I can tell you that the current local time is 2 hours ahead of UTC. Charlie time, that's C, is the one time zone further east, Eastern Europe. So that's the current time there. That includes Helsinki. So I'm going to put that time in H for Helsinki and move on to the next bit, which I was a bit ahead of myself on just now. So this is an I-beam. This is an I-beam because we really don't know what to do with this yet. It's something that I'm playing with, and let me show it to you. If it gets out in 18.0, it will almost certainly still be an I-beam. But DTF here stands for date time formatting. So let us take that time in Helsinki and format it. And this format, as you can see, should give a fairly clear indication of what you'll get when you format this. People who are familiar with .NET's time zone time formatting will see that this is similar but not the same as what it uses. But this has the advantage: days, months, years, they're all in uppercase, hours, minutes, seconds, all in lowercase. Out comes the date and time formatted to that. Let's try a little bit more. If we put only single Ds, we don't get the 0 padding. If we put only 2 Ys, we get 2-digit years. Again, the representation is pretty much what you get. If we want space padding, we can use underscores instead of Ds. And then if we extend now the M's up to 3, we turn into the name of the month. Up to 4, we get a longer version of the name. So we've got the short and long form of the names of 3 and 4 M's. But you will notice that both of those names are a bit shouty in an uppercase. So if we want them formatted as we would like to see them, let's format the M's in the same way. And now we get the month name formatted with a capital at the beginning. So those are the different formats of formatting a month. There is no padding, space padding, 0 padding, short and long form of the text. Got a question from the front.
Introduced the Y10 or Y3K problem. Y10K.
Yeah, you're right. There is a Y10. This will not format more than that. I mean, obviously we could, but actually, the Y. The point was, which I should have repeated sooner, was that there's a Y10K problem there, but the whole of Quad TS has got the same problem. So, or at least the implementation of what I showed you before, that conversion won't go beyond 10,000 either. Anyway, let me show you another format. This is an ISO format of a date using year, week number, and day of week, which is not a very common one, but it exists. So we've got the current date is the first day of the 37th week of 2019, and there's several interesting things going on in there. The first is that I wanted to put a capital W in the result, and W is used elsewhere, as you can see. I'll explain why those are W's in a minute. So I've quoted them, so I can put any literal text in there by quoting it. Another thing to note is that those W's instead of Y's. And you think, why on earth have you used W instead of Y? And that's because sometimes the week year and the actual year don't correspond. So for example, on the 31st of December this year, we will be in day 2 of week 1, 2020. So we have to have a different representation for that year. The other interesting thing there is that D is day of week, and you might be able to predict what's going to come next. If I take the day of week and extend it to 3 characters and I case it as I want it to appear, I'll get the day of the week as well. So I can go back to my original one. I can now put day, month, year, and the time. And one more thing I can do with that is I can put in the ordinal corresponding to the day of the month. So I've got the 9th now. Okay, right. So that's all very well, you might be saying, but you're English and I'm not. So I'm an American. Please format that in a more appropriate style for me. There you can see the day and the month have reversed purely because I have changed the format. And also we've got a 12-hour clock format with AM/PM qualifier. And of course, what you really meant was, no, I don't even speak English. So it's a time in Helsinki, so let us display the time in Finnish. And there is the time in Finnish. What else? Oh yes, if we want to do it in Finnish all the time, then let's change our function definition. We'll use variant to say that Finnish is our default language. And now we don't need to specify it in the format string, it'll come out in Finnish. But if we want English, we can specify that. We can specify Danish, as we're in Denmark. What else have I got? Do French next, I think. Hang on. 12. French, yeah. Russian. There we go. Now, the last thing I promised in the write-up for this was Welsh. There's Welsh, see why. It doesn't work, because I haven't defined Welsh, so clearly there's more to do yet. So, I need to create a namespace as a dictionary. Can I zoom that up a bit? Is that big enough? A bit more? That was yeah, good point. It is in Welsh. You're not supposed to be able to read it. Okay, so I'm going to create a namespace, and I'm going to use some JSON to do that. JSON is the simplest way of forming this namespace. That's why I'm doing it this way. So here's a namespace. In it, it contains one item called CY, which is the language, and then that's a namespace which contains definitions of all the months and long and short forms, the AM/PM indicator, and the ordinals. So let us read that in, turn it to a namespace, change our... Oh, I added this line only this morning. I knew I shouldn't have done that. There you go. I'm just going to show that in the namespace there are the short months along with other things. So change our function. Now that it's going to use Welsh by default, and it knows about Welsh because I pointed at that dictionary. And finally, I can display the name of the current time in Helsinki in Welsh. All right, now as I have plenty of time, I can move on to the last thing. So in all respects, this is going back to what you can currently do, apart from one I'll show you at the end. And this very much ties with what JD was showing you this morning. I'm going to use .NET. So, returning to the Christmas theme, I'm very excited about that particular date. That is the that is in Danish when I expect to be able to open my presents on Christmas morning. And I want to read that into the interpreter as a quad TS format timestamp, so I need to parse that date. Now, I have not written a parser for any dates. I've only written the formatter. We may want to do a parser, but at the moment there is one in .NET, so let's use that instead. So you saw this come from JD this morning. This is setting up all the Danish information. This is the format of that date in the .NET format. It's similar but not the same. And here we go. Let's ask .NET to format it. It's succeeded, and the value we get is one of these OLE automation dates, or we can get it in an OLE automation date. And finally, going back to our quad DT, I can convert that into a quad TS style format, and there we parsed the date and got it into the interpreter. And way ahead of time, I think I just can wish you a happy Christmas. Do we have any questions?